Okay, folks, this is Euclid Book 3, proposition number 17, and we're going to start with a given point, which is A, right up here. See A? This is A. And then we're going to draw a circle called BCD. Well, here's B, and right around here is C, and right around here is D. So BCD. So we got a small circle right here, and we got point A up here. And what Euclid wants you to do is he wants you to draw a line from point A that touches circle BCD. Alright, so how are we going to do this? Well, first of all, I know I'm kind of moving around a little bit. Hang on just a second, folks. Now, the first thing we're going to do is we're going to find the center of BCD. Okay? And we're going to do this by Euclid Book 3, proposition number 1, and we're going to call that point E. And then we're going to draw a line from point A to point E. And if we draw a line from point A to point E, it's going to cross here at point D. Alright, then we're going to draw a line from point D to point F, and it's going to be perpendicular to AE. And I think you remember how to do this from a previous Euclid proof. And I'm not going to go into that. Just know that there's a Euclid proof that tells you how to do this. All right. Now, we're going to draw some more lines. We're going to draw a line from point E to point F. And then we're going to draw another line from point B to point A. Now you say, well, where is point F? Well, you're going to take center E and outermost point A, and you're going to draw another circle. And it's going to be A, F, G. Okay, and that's how we're going to get point F. So, we now have a line that goes from point A to point E, crosses at point D. We have drawn a line perpendicular to AE at point D, and it is DF. We have also drawn a line from point E to point F, and it crosses at point B. And now we have drawn a line from point B to point A. Now we have all the lines we need to make this proof possible. First of all, we have EA and EF. Since EA and EF are two radii of circle AFG, then we can say that EA and EF are equal in length. We can also say that since we have a line from point E to point D and E to B, okay, here's B here, here's D here, we have EB and ED, and they're both equal in size because all radii of a circle are equal. We can also now say that we have an angle and it starts from F, goes to E, goes to A, and we have an angle that starts at A, goes to E, and goes to F. And this angle here, since it's a common angle, it's equal to itself. Well, that gives us side angle side. And I think you remember that from a previous Euclid proof. I'm not going to just give it to you this time. You should know this by now. Since we now have side angle side, we can also say now that DF right here is equal in size to AB, which is right here. Okay? And so therefore, triangle DEF, well, let's start here. DEF, that's one triangle, okay, is equal in size to triangle BEA. There's another triangle. And that also means that angle EDF is equal in size to EBA. Now, at the beginning of the proof, we had drawn a perpendicular line. And that perpendicular line was from point E to point D to point F. Well, actually, the line itself was DF. DF is perpendicular to EA. And because DF is perpendicular to EA, that means the angle EDF here is a right angle. Now, we just established that angle EBA was the same number of degrees as angle EDF. And if EBA is the same number of degrees as EDF, then that means the angle EBA is also a right angle. Wowee! We've proved quite a lot. Now, EB is a radius right here. And because it's a radius, we could actually double that. We could draw it all the way down to, say, another point like right here. Say we made another point right here. We could make this a diameter real quick. Wouldn't be hard at all. Alright. Since we know EB is a diameter, is a radius, and we know that, let's say we make that H, we could actually have drawn a line from point E to point H, sort of like this. Okay? And that would have made a diameter. Alright. Now, we know that line AB touches circle BCD because of Euclid Book 3, proposition number 16. We just got through covering that in the last proof. And that is exactly what Euclid wanted us to prove in the first place, is that AB is touching circle BCD at point B. And that is your proof. I will tell you more in a future video, so stay tuned.